Here we're going to look at an introduction to radicals. So mathematically, if we're given a radical, it looks like a check mark had a baby with a division sign. So it looks like this. This thing is called the radical symbol. And then when there's a number in there, let's say n, that thing itself is called the radicand. If we're given a radical that looks like this, where it's just the radical n, and there's no other additional numbers, that is assumed to be the square root of a number. So we'd be talking about the square root of n. It is itself an operation, much like addition or subtraction, but it's a little bit different because it only requires one number. The square root of n, so that's what number times itself is equal to n, will be the square root of n. Other times with radicals, there could be what's called an index. So we could see a little 3 here, or a 4, or a 5. So that guy here is called the index. And that's changing which root we're finding. So if there's no number, or if there's an index of 2, that would be the square root. If there's an index of 3, that's what's called the cubed root. So that would be what number, so we'll say x times x times x is equal to n. So what number, when you multiply it to itself twice, so x times x times x, x cubed is equal to n. That would be the cubed root. If it has an index of 4, we're looking for the 4th root. 5 would be the 5th root. The next thing we want to talk about, we're going to focus only on square roots for right now and for the next few videos. So the question is, if we have the square root of x squared, is this always equal to the square root of x squared? So are these two expressions always equal? We might try some examples. Okay, well, what if x is, let's keep it nice here, we're taking the square root of a number, so think of a perfect square, 4. What if x is 4? Will this hold up? Okay, well, that would be the square root of 4 squared. The square root of 4 is 2, and 2 squared is 4. Over here, the square root of 4 squared, well, 4 squared is 16, and the square root of 16 is 4. Cool, it worked. Does that mean it always works? Well, we tried something that was nice and positive. What if we tried something that was nice and negative? Why not be nice? How about if x is equal to negative 4? Will this still hold up? The absolute value of negative 4, quantity squared, well, the absolute value of negative 4, that's not a real number. That would go into imaginary numbers. So this we would say no real solution here. No, I'm just going to say no real number. If we look at the right-hand side, let's see if that also is not a real number. The square root of negative 4 squared. Negative 4 squared is positive 16, and the square root of 16 is 4. Well, 4 is a real number, so it does not equal not a real number. So the answer here, no, this is not always true. We need to be careful with that when we're talking about radical expressions.